Okay, in our last video, we learned about those oxidation rules. Now we're going to apply them in actual chemical reactions. We're still going to use those rules when we see how these things combine, but basically, in oxidation or reduction reactions, we're really tracking those electrons and seeing where they're moving, and this just helps us in chemistry to kind of track where the energy is being distributed with those electrons. And so we have two sayings that will help us to kind of track if something is being oxidized or if something is being reduced. Okay, and so the first one is oil rig. Oxidation is losing electrons. Reduction is gaining electrons. That's what that stands for. Or the other saying is Leo says grr. Losing electrons is oxidation and gaining electrons is reduction. Whichever one you want to choose that works for you. I always kind of stick with oil rig, but basically oxidation, we lose electrons, and so that means that its charge will go up. So if I have a -2 charge to start on one side and then it moves to a 0, that means that the charge is going up. So you guys got to kind of know your number line here on this. Reduction means that we are gaining electrons, and so that means that the charge is going down. And so that means if I had a +2 charge and it goes to 0, the charge is being reduced. So let's jump in and do some practice problems together, and then hopefully it'll click a little bit more. But like the last video, you may want to take a screenshot of this or take a picture with your phone so that you can refer to this again. Okay, for oxidation and reduction reactions now, the same rules applied from our previous video on oxidation rules, but now we're taking a look at how those apply to actual reactions. So if you remember from earlier, oxidation is losing electrons, so that means that their charge is going to go up. Reduction is gaining electrons. If I gain extra negative charged electrons, their charge is going to go down. So when we look at these reaction types, we need to take a look at which elements in the reaction are gaining electrons and which ones are losing them, and that's what we're going to do with this one. So if we take a look at a reaction between arsenic and chlorine, it's a synthesis reaction, so those things are going to join together into arsenic chloride. Okay. So we still need to balance this. Okay, arsenic is a -3 charge and chlorine is a -1, so that means that we need to have 3 chlorine ions. Also, can't forget that this is a polyatomic ion. Okay, and so if we take a look at this, I have 3 here and 2 here, so the least common multiple is 6, so 3 times 2 is 6, 2 times 3 is 6, and then we need to put a 2 in front of the arsenic as well. Okay, so that's just balancing it. We need to make sure that we balance these things correctly, because these subscripts of how many we have when we look at their charges is important. Okay, so if you remember the rules from last video, these are pure elements. Okay, so pure elements, they have an oxidation charge of 0. Okay, both of these have a oxidation charge of 0. Okay, now I'm gonna try to find the charges of these on this side and see what happens. So if you remember, chlorine is a -1, but I have 3 of those. It's gonna be a -3 charge. All right, because these are balanced now, this net charge is 0. Okay, so what must this arsenic be to make this work? Well, obviously this needs to be a +3 to make this mathematically true, and I only have 1 arsenic, and so this is a +3 charge. And so now if I take a look at this, okay, arsenic is going from a 0 charge to a +3 charge. So what is happening to its charge? The charge is going up. Okay, so we would say that the arsenic is being oxidized. Okay, so I think on your homework it says something like what's being oxidized. So this is being oxidized, okay, because its charge is going up. And so arsenic is being oxidized. Well, there has to be reduction for this to take place. And so what's going on with the chlorine? So if we take a look at the chlorine, I'll just use a dashed line here. It is going from a 0 charge to a negative charge. So on the number line, that means that its charge is going down. And if a charge is going down, that is reduction. So the chlorine is what is being reduced. Okay, there's one example. All right, here's our second example. This time we have a single replacement reaction between sodium bromide and fluorine. Okay, so sodium bromide, okay, is +1 -1 charge, so I don't need to put any little numbers here. It's going to react with fluorine. Okay, fluorine, if you remember off the diatomics list, it is by itself here, so we need to put that together. So single replacement, fluorine is a negative charge, so these are going to swap places. So we're going to have sodium fluoride and bromine will be by itself. Okay, and bromine is also a diatomic. Okay, sodium's a +1, fluorine's a -1. Okay, so now I just need to balance this. So I have 2 bromines over here, so I need to put in 2 in front of that, which I need to do over here to make sure that that is balanced anyway. Okay, so now we go to our oxidation rules. Well, these are going to be easy. These are pure elements, so those are both going to be 0 for their oxidation charges. Okay, bromine is a -1, sodium is a +1. So I don't need to do any net charges because that equals 0 right off the bat. Okay, so that's what those are going to be. There's no little numbers here either. So sodium is a +1, fluorine is a -1 and that is equal to 0. So those rules are good. So now I need to dissect what is going on here. Okay, so I'm going to take a look at this, and if we take a look at sodium atoms, can you see that there is no change in their charge? Okay, there's no change in the sodium's charge. So these really don't have anything to do with electron movement at all. Okay, so these are called spectator ions. You don't need to identify those in our homework, but if you see those that don't do anything, they're neither oxidized or reduced. Okay, all right, so let's take a look at what is happening to these actual charges, okay, of the other ones. So if you take a look at bromine goes from a negative charge to a 0 charge. So it is actually going up in charge. So that means that bromine is the thing that is being oxidized. All right, and if you take a look at fluorine is going from a 0 to a negative charge. Okay, so since it is going to a negative charge, it is going down in charge. It is what is being reduced. Okay, and so those are the answers for this reaction. We got one more. Okay, on this reaction, we have silver nitrate reacting with barium chloride. Okay, so silver nitrate is AgNO3, plus and -1, so no adjustments on those. It's going to react with barium chloride. Okay, barium is a +2 and chlorine is a -1, so these come down here, so there's 2 chlorines. Okay, so this is a double displacement, so we're going to have silver chloride on this side, +1, -1, and then we're going to have barium nitrate over here. Okay, so barium is a +2, nitrate's a -1, so I have 2 of those. Okay, so now if you take a look at this, we still got to balance it. So I have 2 nitrates here, so I need a 2 in front of this, which I need to put a 2 in front of the silver anyway to take care of the chlorines. Okay, so 2 silvers, 2 nitrates, 1 barium, 2 chlorines. We are good there. All right, so now let's take a look at the oxidation rules, okay, for each of these elements, or compounds, excuse me. So if we take a look at this, right, oxygen is a -2. How many of those do I have? I have 3. So 3 times a -2 is a -6. Okay, this has to equal 0 now. Nitrogen, we're not sure. We're starting on the edges. Silver is a +1. I have 1 of those, so it is a +1 charge. So what has to go here to make this statement to be true? A +5. So that means nitrogen is a +5. Okay. Now take a look at barium chloride. Chlorine is a -1. I have 2 of those, so this is a -2. Okay, barium has to be a +2 in this to make this mathematically work. Well, I only have 1 of those, so barium is a +2 for its numbers. Okay. All right, silver chloride. All right, so silver, these are all by themselves, so chlorine's a -1, silver is a +1, and that equals 0. And lastly, barium nitrate. Oxygen's a -2. How many do I have? I have 6 of those. 6 minus 2's is a -12. So that's going to equal 0. Barium is a +2. Okay. So what has to go here for this statement to be true? Well, this has to be a +10. How many nitrogens do I have? Let me write this back up here. How many nitrogens do I have? I have 2 of those. So what number times 2 is going to give me a +10? That has to be a +5. Now, if we take a look at this, can you see that nitrogens are both 5s? So nothing's happening. Okay. Well, maybe that's just my spectator. Let's take a look at the silvers. Silvers. +1, -1. There's nothing happening there either. Chlorines. -1, -1. This is weird. And lastly, the last one to check. No, we got to look at the oxygens. We got a couple. Oxygens are -2, and over here, -2. Huh? Bariums, +2. Bariums, +2. There's nothing happening with any of these. So what does that mean? There's an equal amount of trading of electrons. There's no gaining electrons. There's no losing electrons. And so if we see this in a reaction, we just simply write no redox. Okay, it's not a oxidation or reduction reaction. So just be on the lookout for those as well.